All right, let's get through this review sheet together. So up top I said you guys had to do 1, 5, 6, 7, 9, and 12. I'm just going to go do all of them just so you have that. So first we're solving using either substitution or elimination, so just whatever's easier. In this case, it looks like I can use substitution. Both are equal to y. So, if you think about it, y is equal to itself, right? So you can do one side, 3x, the other side, negative x plus 4. Let's get the x by itself. So I'm going to add x to both sides. 4x equals 4. Divide. We have x equals 1. Okay. Get y by plugging in x. So y equals 3x, y equals 3 times 1, or y equals 3. We'll write our answer as a coordinate point, 1, 3. The second equation, I'm going to solve this with substitution again, actually, because I see 6y in both equations. Let's do that. Let's see what happens. 3x plus, now 6y is equal to negative 3x plus 18 is equal to 18. It looks like there's nothing to do in these parentheses, so I'm going to take them away. Plus minus, so plus negative we can write as minus, so 3x minus 3x plus 18. The 3x's are going to cancel. We get 18 is equal to 18. So what does that mean? Well, we have a true statement that is true regardless of whatever I choose for x or y. So that means we will have infinite solutions. Okay, this is actually a case where if we were to solve both of these for y and graph them, we'd have one line graphed on top of another, the same line. Okay, number 6. So determine if the points are solutions to the following inequalities and systems by plugging in. So let's plug in the point 2, 1. Now remember, this is x, y. So 2 minus negative 1 less than or equal to 3. 2 minus negative 1, that's the same as 2 plus 1. So is 3 less than or equal to itself? Yes, that is true because of the or equal to part of the statement. So this is a solution. Number 7, we have the point 0, 3. Again, there's our x, there's our y. Let's plug it in. So first equation, we have 3 is equal to negative 0 plus 3. Well, negative 1 times 0 is just 0. So is 3 equal to itself? Yes. Second equation, 3 equals 4 times 0 minus 2. 4 times 0 is 0. Now, is 3 equal to negative 2? No. That is not correct. So this is not a solution. So 0, 3 is not a solution. Okay. What this means is, one of the lines is going to go through 0, 3. So, if this point represents if this point represents our 0, 3, maybe this line goes through it, right? One line goes through, the other line doesn't. Okay, but their intersection point is somewhere else. Okay, number 8, we're solving algebraically. So write our let statements. We need let. Use elimination or substitution. Okay, so I buy 8 mangoes and 3 apples for $18, 3 mangoes and 5 apples for $14.50. How much does each mango and apple cost? So let's let M equal mangoes and A equal apples. Then I have 8 mangoes plus 3 apples totals out to $18. 3 mangoes and 5 apples comes out to $14.50. Now I can solve with elimination or substitution. I'm going to choose elimination here. Okay. Now it's not entirely clear what I should multiply by because the coefficients for m, they're not multiples or factors of another. Same with the coefficients for a. So what I'm going to do is I'm going to multiply. Let's get rid of the a's. Okay. So if I did 3 times 5, I would get 15. So I want to change both of these coefficients to 15, except one of them is negative. Let's make the bottom one negative. To do that, I'll multiply the top by 5 and the bottom by negative 3. So distributing 5 to all 3 terms, that gives me 40m plus 15a equals, let's see, 5 times 18, I believe that is 90. Now we distribute the negative 3. Got to remember the negative. Okay, so negative 9m minus 15a equals, let's see, negative 3 times 1450. Let's use our calculator real quick. Oops. So we'll do negative 3 times 14.5. Negative 43.5. Okay. Add everything up. Let's see, the 15 A's are going to cancel. We're left with 40 minus 9, so 31 m. 90 minus 43.5. Yeah, I think we're going to need the calculator for that one too. So we'll do 90 minus 43.5 gives me 46.5. Okay. Now let's go ahead and get m by itself. Divide both sides by 31. M equals, what does this come out to? Divided by 31. 1.5. Oh, that was better than I thought. I was expecting a kind of gross decimal there. So M equals 1.5, or in other words, mangoes cost $1.50. So to solve for A, we're just going to pick whichever equation we want to work with. I'm going to work with the first one. We'll plug in. So 8m plus 3a equals 18. 8 times 1.5. Let's see. 8 times 1 is 8. Half of 8 is 4. So 8 times 1.5 should be 8 plus 4, which is 12. Plus 3a equals 18. Subtract 12 from both sides. We got 3a equals 18 minus 12, or 6. Divide both sides by 3, and a equals 2. So apples cost $2. All right, number 9, the sum of the distances 2 hikers walked is 53 miles, and the difference is 25 miles. What are the two distances? So this one might be kind of tricky because it feels like you're not given enough information. We know there's 2 hikers. We want to know the distances that they walked. So let's let one variable, we'll use x for the first hiker, hiker 1. We'll use y for the second hiker. Hiker 2. Okay, now when we found the sum, so we added the distances that they walked, so x plus y equals 53. The difference between what they walked, so x minus y, is 25. Okay, what are the distances? So we can solve by either elimination or substitution. I think elimination will be easy here because if we add both of these together, the y's are going to cancel. So we add them up, we get 2x equals 53 plus 25. That's 78. Okay, divide both sides by 2. So hiker 1 hiked 39 miles. Okay, to find hiker 2, let's use the first equation. So 39 plus y equals 53. Subtract 39 from both sides. I have y equals 14 miles. So that's how much hiker 2 hiked. Okay. A coin bank has 250 coins, dimes and quarters, or 39.25. Okay, how many of each type of coin are there? So we know there's only dimes and quarters. So let's use D for dimes. Let's use Q for quarters. Okay. Now there's 250 coins. If we add up the dimes and the quarters, we get 250. If you add up their values, they're worth $39.25. So we have dimes, which are worth what? 10 cents. Well, let's think about this in terms of dollars, right? So a dime is $0.1. Right? So 0.1 dimes. A quarter is $0.25. So 0.25 Q equals 39.25. Another way you could do it is you could think about the number of cents. So you could move the decimal point over 2 places, and you could write it as, essentially we're multiplying everything by 100 here, so 10 cents per dime plus 25 cents per quarter equals 39.25 total cents. I think this second way might be a little bit easier. Okay, let's do elimination here. So what would I multiply? I'm going to multiply the top by negative 10. That'll get rid of the dimes. So we have negative 10D minus 10Q equals negative 2,500 plus 10D plus 25Q, which is 39.25. So our dimes cancel, giving us negative 10Q plus 25Q, or 15Q, and negative 2,500 plus 39.25. Let's see what that comes out to. So I'm going to write this as 39.25 minus 2,500, 14.25. Divide both sides by 15. And we have $95 quarters. So we have 95 quarters total. For the number of dimes, we know that they add up to 250, so D plus 95 equals 250. Subtract 95 from both sides. So 250 minus 95, 155. So we have 155 dimes. All right, next page. So we're solving these graphically. We still need let statements. So Mark is a student. He can work for at most 10 hours a week. So we already know that we're going to have an inequality where his number of hours is at most. So less than or equal to 10 per week. Okay? He needs to earn at least $44 to cover his weekly expenses. So he needs to earn greater than or equal to $44 per week. Okay. His dog walking job pays $5 per hour, and his car wash attendant job pays $4 per hour. So those are his two jobs. So let's let, now we're graphing, we need x's and y's here. So let's let x equal his dog walking job, and let's let y equal his car washing job. Okay, so taking the equation for his hours, if he works x hours walking dogs plus y hours walking or washing cars, that needs to be less than or equal to 10. Solving this for y, because we need to graph, we subtract x from both sides. And that gives us y is less than or equal to negative x plus 10 or 10 minus x. I'm going to write it this way. And we're counting by ones. 1, 2, 3, 4, 5. So there's 10. So he's starting 10. And our slope, negative 1 over 1. So down 1 over 1. I know it's not perfect considering the scale, but that's okay. Okay. Let's change colors here. So for his money earned, he makes $5 per hour walking dogs and $4 per hour washing cars. This guy is severely underpaid. Needs to be greater than $44 a week. Let's solve for y. So we're going to subtract 5x from both sides. 4y greater than or equal to negative 5x plus 44. And we will divide everything by 4, giving us y is greater than or equal to negative 5 over 4 x plus 11. All right, so his y-intercept for the other equation is 11. So let's finish this out. I know this is, for the green line, less than or equal to, so it's going to be solid. Okay. And I'm going to need to shade below because it's less than or equal to, so I'm going to shade below. All right. For his blue line, that is his job, What's our slope? Wrong color. -5/4. So down 5, right 4. So we're going to go down 1, 2, 3, 4, 5, and right 1, 2, 3, 4. Down 5, 1, 2, 3, 4, 5, right 1, 2, 3, 4. Okay, now I definitely should have changed the scale. It would have been much easier to see the overlap here. My bad. This is shade above. Okay, we're going to have to shade above because it's greater than or equal to. And you can see right here is our little overlap region. Okay, and it's not really, it doesn't really shade well, the blue and the green together. So we'll color that with a different color. Okay, so we shade above. In our overlapping region, it's going to be right here. So there's our little solution space. Okay, Jackie's limo service charges a $3 fee plus 50 cents per mile. $3 fee plus 50 cents per mile. Her friend Bob starts a rival service where it's $80 per mile, but no fee. Okay, so we need an equation for each limo service. So for Jackie, okay, let's let y equal the cost in dollars, and x is going to be miles. Okay, we know that's the case because the cost is dependent on the miles, right? Your y is always your dependent variable. So we'll say the cost is, now it's a starting fee of $3 plus 50 cents per mile. Bob has no starting fee plus 80 cents per mile. Let's see which one is the better deal. So we'll graph Jackie in blue, and we'll do Bob in red. So let's see, 1, 2, 3. So Jackie, 3 plus 0.5x. What is 0.5 as a fraction? It's 1/2. So up 1, right 2. Up 1, right 2. And let's let our x-axis be the same scale as our y-axis. All right, up 1, right 2. Let's keep doing that a couple more times. No inequality, so we don't have to worry about shading. All right, we'll graph Bob in red. So his y-intercept is going to be 0. He's starting down at the origin. His slope, which is 0.8, let's convert that to a fraction. So that'll be 8/10 or 4/5. And if you ever are confused, you can always just use math, enter. 0.8, math, frac, bonk, 4/5. So up 4, right 5. Okay, up 1, 2, 3, 4, right 1, 2, 3, 4, 5. Up 4 more. 1, 2, 3, 4. Right, 5. Oh, there's our intersection point. Okay, so it looks like they intersect at the point 10, 8. So using our graph, we need to determine the number of miles you would travel to make Jackie's limo service the better choice, okay? And so by better choice, we mean the lower cost. Okay, so if we look at these lines, the y value is the cost. So essentially this is saying, at what point is Jackie's line below Bob's line? Okay, before 10, she's more expensive, and after 10, she's less expensive. So we would say after 10 miles, Jackie is the better deal.